Hello, and welcome to Arizona State University and our chapter of PMSE. My name is Clarissa.
And I'm Rose.
And today we have a very simple demonstration for you that involves water and packing peanuts. So Rose, what do you think is going to happen when we put packing peanuts in water?
I mean, we've used these a million times before. I don't think anything is really going to happen.
Well, let's see. So we put them in water and there's not really anything happening with my packing peanut.
But mine dissolved almost instantly. Why do you think that is?
Well, turns out these are actually different types of packing peanuts. Mine is made out of polystyrene, which we can think of like these entangled coils. So they are stuck in this conformation when they're outside of the water, and when we put them in the water, there's nothing very interesting about the water itself, so they stay in that same conformation.
My packing peanuts are made out of a starch. And starches look a lot similar to the polystyrene, except they have these hydrophilic groups, or groups that really love water. So that way in air, they look the same as polystyrene, but then once you introduce them to water, they start to uncoil from each other and eventually just dissolve. And this is a big part of what makes some materials biodegradable. And it's a huge step forward for single-use plastics, so that way we know that they're not just going to build up in our landfill. But what happens when it rains? You don't always want your materials to just dissolve as soon as they get introduced to water. And that is where recycling comes in. And there are two main different types of recycling that we've developed over the years: mechanical recycling and chemical recycling.
So mechanical recycling is what we typically think of when we think of recycling. A lot of those water bottles, milk jugs that we throw into recycling bins end up at mechanical recycling plants. And so they take those plastics in those conformations and they grind them up and break them down, and then they introduce them to a lot of heat where these chains can unentangle and then reform into new shapes.
And this is a concept that's actually used in a lot of 3D printing. So if you think about, a PLA filament printer, what it's really doing is it's taking that spool of filament, heating it up so that way it flows, and then turning it into interesting and new shapes like this keychain that we made.
But mechanical recycling isn't perfect. When it's going through that grinding and heating process, it's very common for chains to break into smaller pieces, and that makes it harder for them to entangle in their new forms, and their properties aren't often as good, which is why your water bottle doesn't always become a water bottle. Sometimes it is recycled into a pair of jeans instead. And something else with this is if the sorting isn't as good as it can be, there can be different types of polymers in the mix that reduce the properties because they don't like being mixed together. They would rather be as far apart from each other as they possibly can be.
So in order to address some of the problems that we have with mechanical recycling, chemists have been developing a new form of recycling called chemical recycling. What chemical recycling is you're taking your more traditional polymers, but you're installing different areas or different functional groups on the polymer that allow us to actually break it down into their base components. And what that does is it allows us to take those, repolymerize them, and make them into different shapes like before, but without losing any of that mechanical integrity, because now you're still getting the same length of polymer that can re-entangle. And what it's also doing is it's going through purification processes that allow us to prevent other plastics from getting mixed in or other impurities from getting in there and reducing our properties. And this is exciting because now we can still have a lot of the new exciting polymers that exist today in all of our plastics, but it ensures that we have a more sustainable future because we can, take those, reform them, and maintain and create a lot of the same materials as before. And that creates a more sustainable future for us.
So next time you see a packing peanut or a water bottle, you can remember there are different types of recycling and a lot of very interesting research going into making our world more sustainable.